Hello, everybody. Welcome this afternoon. Today I will talk about human factors engineering for IT security. I'm human-computer interaction researcher at CURE. What I will talk about today, I will give a short introduction about CURE, the Center for Usability, Research and Engineering. We are located here in Vienna. I will give an introduction to usability in relation to IT security system design. So from my point of view, the talk is more about the design of security systems, especially, of course, the design of graphical user interfaces for security systems. I will touch the topic of mental models because this is a very important issue for HCI research and security. I will talk about user experience and give some example how to utilize it in the design of IT security. I will then go through the challenges we face when designing such systems. And then I will go into the design process and hope I can show you how to tackle the challenges we face. And I will sum up with some conclusions, of course. Okay, CURE, the Center for Usability, Research and Engineering, where I come from, is a non-profit research organization. We're a spin-off of the University of Vienna since 1998. We have an industrial consulting partner called USCON. Internally, we are a team over 25 people, but we are not technological people. So our team comes from cognitive psychology, social sciences, and so on. The HCI security team, human interaction, and security, we are 5 people, and CURE is very experienced in national and international research projects, where one of the biggest we coordinate now is the uTRUSTit project. I will give you a short overview as I reference the project later on. It's a 3-year project funded by the European Commission. I already told you that CURE is the coordinator, and on the right side you see our partners there. Okay, usability. Especially usability and IT security. We know that human behavior, when it comes to security systems, can be some kind very demotivating for us when we are looking for security. This picture only shows one effect. People invest a lot of money in security technology and end users just circumvent it. This is, in fact, not the only reason why we want usability for security systems, because we, in general, do not only want to avoid that we spend money on technologies people do not use, for example, as a company boss. When we are a company which develops security systems, we, of course, also want to avoid damage. We don't want all the users of our new super firewall product to call the hotline every 10 minutes because they say, hey, since I bought your product, nothing does work anymore. What it's all about is to maintain what we call holistic security. Security which includes the end user and is not only limited to the technological part, sorry. For IT security systems, there is what we call the principle of psychological acceptance. You can read it, I won't read it word by word, but it boils down that if you design your IT security systems in a way that it's unusable, users either won't use it or will use it the wrong way, which then, of course, very often circumvents the security of the systems. And we know this since 1975 already, as you see in the reference. There is a very abstract definition by an ISO standard what usability is. They say it's the effectiveness, efficiency, and satisfaction with which specified users achieve specified goals in specified contexts. The standard does not really talk about the methods. It's very abstract and will not really help when you are designing IT security systems. It does not really help in concrete design decisions. This is why I will later break down this definition in usability principles, where I will give examples then. First of all, I will give an insight into our practical experience. So how do people read this standard? Sadly enough, most people read it the first way. I tried to do it with the font size to see how people emphasize efficiency as one of the usability principles over most of the others. Especially developers who live in a classical program, compile, test, re-engineer cycle tend to maximize efficiency over all other aspects because it makes their development work easier. This is one danger because we will later see that we have a lot of principles and it's not always the best to maximize this one. Okay, I will come up with 12 principles. All these principles, they enable usability. When those principles, I will explain, are obeyed, software you produce is learnable, it's efficient, it's effective, and it's satisfying and fun to use would be the best. The first principle, consistency. So, one example of consistency, if you drive a car or a Mercedes, for example, and you change to a Porsche, you still will be able to operate it because the user interface elements are consistent even if the design is very distinct. When it comes to the IT security domain, one positive example for this consistency is, as far as I have seen, that the lock for secure connections is consistently used over different applications. So it's not the bad way where one application uses a lock to symbolize a secure connection, another application uses maybe a chain for a secure connection, or so on. This would introduce inconsistency, hence lower usability. And we want to boost usability. The next principle is feedback. If I ask you, hey, how are you today? Yeah, and the system does not react because that makes me crazy, because I don't get feedback. I, as an end user, I do not know, did my action do something to the system or not? A very classical example is, was in former web times where you had this nice effect that people could, with a click on a search button, restart the search process. So they clicked on the search button, no feedback happened, they think nothing happens in the background, they click again, and so they put themselves in a never-ending loop. I already have been talking about efficiency, a principle which developers tend to maximize. In general, all these principles have to be combined in trade-offs. So you need to know your end users, and then you can say, okay, for this end user group, I have to maximize this or that principle. For another end user group, for example, if you develop for your own community, for developers, then maybe working to boost the efficiency principle is a very good idea. If you want to do a personal firewall for the Aunt Annies of the world, then maybe learnability would be the thing to maximize and not efficiency. The next principle, flexibility. Just as an example from the security domain, flexibility could mean you build a laptop and you provide more than one means for authentication. For example, my laptop only has USB and password and user ID as authentication. I do not have a smart card reader in there. I also do not have a fingerprint reader in there. But such system would add to the principle of flexibility, as the user would have more than one way to accomplish the task of authentication. And this is flexibility, and this would add to usability. Not all of the principles are weighted equally, as I already said, and some of them are very discussionable in the area of IT security. Clearly marked exit just means do not provide dead ends for users. Just don't let them drive into one-way streets without a way to come back. But if you imagine now what to do with, for example, an invalid certificate. You want the user to have a one-way there, because when the certificate is invalid, the user should maintain security and not go to the site. So one could now discuss from a security point of view if providing the button ignore, for example, if this would be a good idea. Maybe it would be a good idea from a usability standpoint, but maybe it would not be that good of an idea from a security standpoint. But as the usability definition always talks about also specified contexts, we have to look at the context. Maybe in one context it is okay to provide this, in another context, maybe not. Now, this principle is one which I would really keep an eye on when I design IT security systems. Why? Because experience has shown that this is one of the greatest sources of problems. I will show an example later on, so I will not talk very long about it here now. The next principle is task orientation. Build systems that support the tasks of the users. As far as I have seen in my private life, my adults and so on, they never did backups. I always tell them, back up your data. And of course, they never do. The tools are not really in place. They are not task-oriented. But I know some people who do it. All they use time machine. So security technology can be sexy, and it can be designed in a way that it is very aesthetical and very pleasing, and then people also like to use it. Control means more the feeling of control. So users need to have the feeling of control when sitting in front of the machine. If it's the other way around, then we have a big usability problem, and people are likely to change their system or to not use it anyway. Recovery and forgiveness is the next principle. Humans err. So good software and good general systems, not only software, it's also hardware and so on, they are built in the way that humans can recover from errors, therefore. The next principle is minimize memory load, which can be boiled down to don't rely on knowledge in the user's head too much. It's not about the authentication knowledge like a PIN, it's about how things work. And for example, don't rely on the user having read the 300-page manual. Another principle where I would, very similarly to wording in user's language, keep a focus on when designing IT security systems is transparency. The problem here is that the users have to do security decisions. And in the best way, these are informed security decisions. So the system has to be in a way transparent that users have a chance to recognize which decision they should take. Last but not least, every artifact humans build have an aesthetical and emotional effect, if you want it or not. So if you build, for example, a device which has the aesthetics of a brick, then people will have the user experience. Hey, that's just a brick. So you build a device that has a very sexy and slick aesthetic and emotional effect, which could be, for example, boosted by using expensive materials and so on. This principle is everything you build, if you build it aesthetically and with a positive emotional effect, will have more success. In terms of IT security systems, it will be used better and in a more correct way. Okay, now a small example. Maybe you know this neat little security technology. From a real end user's point of view now. Let's again talk about the Aunt Annes of the world. So my Aunt Anne is sitting in front of the computer and needs to connect to the VPN network. But when she sees such a screen, she thinks, what is OpenVPN.exe? Because she clicked on VPN connection. So there is no explicit relationship. By the way, she does not even distinguish much between an operating system and a binary, but this is information which confuses her and does not help her. And it goes on like this. As I said, the problem in IT security systems is that it's filled up with very technological acronyms, with very technological speech, and the man on the street will never ever have a chance to understand what is a destination IP, or what does this mean. So maybe some users already have a very nice clue about how the domain names are constructed, but most users still do not get in contact with IP addresses. I have been talking about transparency already. Some information is given here which does also not really help the end user to make the final decision, because the final decision has to be, should I click on allow or deny, more or less. Another thing, a small issue, is if you provide such a checkbox and it's more or less one-way ask, then users, of course, always doubt, how can I uncheck it if I want it again? But all these small questions popping up in the head of an end user are very small compared to the main one. What does it imply when I click on one of the buttons? So if you look at the picture now, there are a lot of open questions in the head of the end user. We know the human brain is designed to make sense out of things. So the man from the street is not able to answer these questions, but the human brain makes sense of the things it sees. So what it boils down is, the user interface just tells me, if you want to proceed, click allow. If you also do not want to be bothered in the future, also activate remember this setting. So this is more or less what the user sees. And this is what we should avoid, because as you see, what we have reached is exactly the opposite of what was the goal. There are some people having done some investigations on this issue. Just to provide you a small example how things can get better also. This is a screenshot from a research prototype. What happens here? I'm sorry, it's only a screenshot. The animation would be better. What this guy has implemented is, instead of just having a pop-up like allow deny for a connection, the left blue plane is the desktop flipped in a 3D effect to the side. You might recognize the browser windows, and you know they are browser windows because they have connections to machines and the internet. So you see what's your computer, you see machines where the things are connected, you get more information about the machine, and it's visually much more clear that connections are happening, where they are happening, and in fact what you do here is just drag and drop the cables or undrag them from the destination, so you forbid the connection. Still, this does not solve all the problems, because you always have these background processes running. These are the green boxes below, and end users in the usability test, which was done with this prototype, they have not been really sure what these green boxes are all about, because they have no working mental model about background processes, which brings me already to the next topic, mental models. What happens when IT security systems are designed? We have a developer. The developer has a mental model of the application he or she wants to build. He or she is thinking in classes, in functions, in database models. On the opposite, the end user. The end user has the end user's mental model in the head. And this user's mental model is constructed by what we call the system image. Why? Because the developer implements his mental model in the system. The system has only the graphical user interface, and an audio interface, of course, to the end user to explain the mental model of the developers. As you see, there is no direct connection from the head of the developer to the head of the user, which would be very convenient, because then every user would see, this is why the developer labeled the button ID X, or and this is why it's called HTTPS and not HTTP, and so on. So The user is thinking in tasks and goals and feelings. The user does not think in security. So what is a mental model in concrete? I again don't read the whole definition, but it boils down that when humans see something, they build a mental model because they have some internal model of how the world works. Why is this so important? Human-computer interaction and usability engineers always say when it comes to the design of usable systems, know your end user, include your end user as early as possible in the project. But when it comes to the design of IT security systems, I would extend it to not only know your user, I would extend it to understand your user. There is a very classical HCI security paper called Why Johnny Can't Encrypt, where it's about the usability of PGP 5.0, where PGP 5.0 was built obeying standard usability design guidelines for graphical user interface design. So from a classical usability point of view, this application would have been very good, but the usability tests have shown that people did not understand the complex mechanisms in the background. They did not really understand the key pairing, and for example, they were given a task to send out their public keys, and about, I think, don't beat me, but I remember 40% of them sent out the private key. And so, in fact, the usability of the application was great, but what was missing was to understand the mental model of the end user, which is very important because you need to know how people think the world is working, that you can design an application which fulfills the principle of task orientation. I will give a short example from Cure's research. Cure has been very active in the Prime Life projects where we dealt with privacy-enhancing technologies. We wanted to know what is the mental model of end users when it comes to how their data travels to the web. What did we do? The task was, you are sitting in Vienna, you are opening your Facebook account, and you are typing in a message, and your friend in Paris reads it. Then we gave our test participants the map and said, okay, you are sitting here, this is Paris. Now, here is the pen, draw for us, how do you think the data is wandering through the web? Frankly speaking, I took the most extreme example here because this user really said, oh yeah, I use Microsoft, so Microsoft knows everything I do. So it has to be the case that from my computer, maybe, and this is not that bad. In former times, users thought when they call Google, they have a direct connection to Google, which would completely undermine every explanation of a man-in-the-middle attack. As you see, they already know that it's not really direct. So this guy has one hop in Spain or something. Okay, it's a little bit too less, but the thing, and I think it's not really that funny, is that he thought Microsoft reads everything. And this is also the conclusion from the study we did, because most of the people thought the data is somehow observed by the USA. I just picked the Microsoft example because it's the funniest one. But I think 6 out of 10 people in our study had some very similar idea of the data is always somehow routed through the US. So now we know what is the foundation for security decisions when it comes to data traveling through the web. If you would now want to enhance IT security application, maybe it's simply enough that maybe we visualize somehow the traffic to bring up the awareness that the data is not always going through the US. The next concept, which is broader than usability, is user experience. User experience is a heavily cognitive psychological concept where we accumulate a lot of different factors like privacy, trust, fun, but also usability is a user experience factor. I will just line out two examples where user experience can be used in a positive but also a negative way in IT security. The first example, the positive one, is about authentication. In this study, 3 authentication tokens were evaluated. Okay, 1 smart card, 1 authentication token, and 1 authentication token with some storage facility. I picked out learnability and security interaction with the token versus the token plus storage. When we look at learnability, we see, of course, that a little bit more technical complexity, it's providing the token and the storage, hinders the learnability a little bit. But the interesting thing really is, on the right side, the security interaction. So from a technical point of view, the token versus the token with some storage is nearly identical. From the user experience point of view, what happened? The study setup was that different user groups got this authentication tools for some time and then filled out the questionnaire. So 1 is a rating for poor, 7 is a rating for excellent, so 2 points difference in security interaction is rather a good result. And this only because we have storage. And the background is not that storage for itself is that cool, but what happened was that during the study participants put private material on the storage. So this small piece of device was not only worth a token for authentication, and it was not only worth 10 megabytes of storage or something, it was worth private photos. And therefore, this user experience factor led to the fact that the token with storage succeeded really great compared to the other authentication mechanisms. So I think this is really a very good example on how to utilize user experience for positive security. Of course, this human behavior can also be utilized for malicious attacks. You might know this road apple attack where you accidentally lose prepared USB sticks which are prepared with malicious stuff. The pictures I took, technically in both cases there is the same malicious stuff in there. From the outside we have 2 devices with very different user experience. You might now say, yeah, but maybe somebody hates duckies, so I would like to use the USB stick because it looks more standardized. But if it's a targeted attack, maybe you have done some research to your target, and then you might already see why you can utilize user experience factors also for such attacks, because of course, the hypothesis is that if you do the ducky attack with this colleague, then it would be much more, the chance would be much more higher to succeed than when using the standard USB storage looking like device. So what are now the challenges in the design? One of the first very big challenges that security is not the primary task of users. No ordinary user goes home at 7 o'clock in the evening and says, hey, what do I do today evening? Let's do 2 hours of firewall configuration. Security is always a secondary task because end users always have another task in mind. And yes, they want to complete the task in a secure way, but they expect it from the system that they are not harmed. So what the fact is that users focus on the primary task and therefore might not solve the secondary task of usability. Let's say I will be very likely to ignore a not safe connection if this is the only shop where I get this book my wife wants. So I will ignore the security task there. Another point is, and especially when we look at Web 2.0, that the security concepts and the general concepts get much, much more complex. As I already said, we only have the graphical user interface primary to communicate with the end user. This is really a big challenge. Imagine, for example, complex privacy stuff like anonymous credentials, which are not very widely spread until now, but which is a very complex concept, and it will be very hard to build applications which communicate this complex concept accordingly. I also have already been talking about informed decisions, and they are really hard to undertake because users, as we have seen, very often miss a working mental model. And another problem is that graphical user interfaces often support the wrong mental model, like the lady on the right side. It's a piece of paper. Why can it be dangerous? So this icon does not reveal that it actually could be a very dangerous piece of paper. And also, the graphical user interface elements are very often hard to interpret, I said already, most of the time due to a very technical wording. Yeah, the technical wording, I am repeating it very often because this is really one of the greatest problems. The technical language is very hard to understand. The thing is also that the user's perception of trust. We very often see a lack of transparency of the underlying security properties, so users cannot really build up trust in security solutions. So the solution for the end user is then just to not use it. We have, of course, a very big problem because of the lack of possible consequences. Most users, as the colleagues before already said, I have no money in my bank. Why am I at risk and such things? And another big challenge is that we as humans, maybe we think we are very rational when we do decisions, but in fact, human risk analysis is a heuristic one. It was very appropriate to escape a saber-toothed tiger in former times, but it might not really be the appropriate approach for online security decisions. So we have heard a lot of challenges now, so how to solve them? ISO in general states a user-centered design process, which is defined. We see here one iteration. It is more or less identifying the need for human-centric design, do some specification, specify the requirements, produce some prototypes or design solutions, evaluate them, and then iterate it again. Cure's experience in the last years, especially when it's about security and privacy-enhancing technologies, is that at least 5 iterations are needed for most of the dialogue screens we built, because especially in the privacy domain, a lot of new things are happening, and this adds to the problem that end users cannot have long-term or even short-term experience with new things. So this, of course, opens up the discussion for where and how should we train not only ourselves, but also our children in IT security. Again, the ISO definition is like the definition for usability, very abstract and does not really tell you how to concretely approach the things. I only have 3 iterations on this slide now, but the thing is that we suggest to tackle these challenges, we apply a mix of classical HCI methodology like personas or retrospective testing, but we also add new research to it. I already stressed the importance of mental model research. Classical usability evaluation is more based on task times and error rates, whereas HCI security evaluations are based on the deep understanding of what has happened. I will now go through an example process. I already mentioned the uTRUSTit project in the beginning. In the uTRUSTit project, we start with classical personas. Personas are not Alice and Bob. Alice and Bob are stereotypes. Personas are based on data, and they are more or less prototypically persons. They are archetypes, not stereotypes. Those personas are then used to bring scenarios alive. So the idea is, as we know that the personality of different people influences the usage and the interaction with IT security applications, we know that the user as the one definition of what we want to build the system for is not enough. So we have a multitude of personas, you see them on the right, and they represent more or less different user groups. And this goes back again to the definition of usability, specified users. Personas is, from our point of view, a very efficient, very lightweight, and very unintrusive method on how to achieve this. Of course, we also do user studies. Besides the classical laboratory evaluations of different prototypes or parts of prototypes, we do this mental model research. For the uTRUSTit project, as I said, it's very hard to evaluate things which are not in place. We try to do some evaluation in virtual reality environments. And one important point is that, of course, we use design guidelines in the project. These design guidelines you might know for operating systems. In our case, we iterate them and focus them on the application domain, which is Internet of Things in the uTRUSTit project. But the idea is that you have general graphical user interface design guidelines for producing general applications like Office applications or something. But for the design of IT security systems, we need to go deeper. We need to better define, for example, the wording, as I stressed already a lot. And of course, we also go an iterative approach with this design guidelines. So based on our user studies, we come up with basic design guidelines, and then based on ongoing studies, we iterate also the guidelines to be then able to provide a set of guidelines when the project is finished. Before finishing the project, we of course also have end user trials, the classical ones, which then already include hopefully working prototypes. It will be in 1.5 years. Just to give you a brief introduction to the personas, I picked out one sample personas, Frederick Claassen. We have a whole family, the Claassens. And this guy has dyslexia. He uses assistive technologies when he has to read a lot on the screen. Still, he likes technology. And he, of course, is the young guy in the family who supports the adults when things don't work. Yeah, based on his dyslexia, he tries to avoid reading, but he's still always online. This is just one of the personas. You see already from the short descriptions. In the original, there are very long descriptions, but you can already anticipate that there are a lot of implications for user interface design on these persona descriptions. And when you have a set of those persona descriptions, you have already a lot of design implications. So you can personas not only see as a definition tool for your peer user groups, but also as a design tool, and you also can use them for evaluation later on. To conclude my talk, I will sum up. Why do we need usability? We said we want to maintain holistic security. We want that the users use our security applications, and when they use it, we want that they use them in the right way and don't undermine security by using it the wrong way. I think nothing is worse than believing to be secure and actually not being secure. How? Use real end users. Don't base your decisions on opinions. Base your decisions on real end-user data. Specify those users. I introduced the personas method, a very nice one. We recommend it, but there are different ones. I recommend to avoid to talk about the user. If I ask you what you think is the user, and if I ask you what you think is the user, I will get two totally different pictures of the user. This is why it's a very good idea to define them. And as we are all humans, we are empathic to other humans. The method suggests to using photos, and this is why it works on a very subtle basis, because it works because humans are empathic to others. The how is, I really recommend to introduce the end user as early as possible in the project, maybe even before 0.0. It would be nice before 0.0 to already know how is my user group talking about technology, how is my user group talking about security, which words are they using, what will they understand if I call things X, Y, Z or something. I also stressed the mental model research. It's very important to know how the people think the things work, because only then we can analyze why things won't work out if we experience, for example, that users send their private and not their public key parts away. And of course, iterative end-user testing and re-engineering, 5, 6, 7 iterations I expect. I really recommend this. Because all in all, it's not about security versus usability, it's about designing usable security systems. Because our users, they are not the enemy. Thank you.